This is like your warm-up, because it is your warm-up. Alright, the idea is go systematically. Take care of one segment at a time. So, if they ask for AB, go after AB. Now, if you choose a different segment, it doesn't matter. One way that I calculate slope, we can use the equation, and you can always use the equation. The slope m is equal to y2 minus y1 over x2 minus x1. You can always use that, which is the change in y over the change in x. But the last time I was teaching Algebra 1, I said, all right, let's try to, sometimes remembering these formulas doesn't really work out that great. Let's try to remember maybe a different way, an easier way to make this happen. And we came up with just creating a table of values where I'm going to put point A and point B in the two lines, or in the two parts here. A is at 3, 3. B is at 0, 4. And now I have my x's lined up, I have my y's lined up. What do I do with the x's and the y's? I subtract them. So I put parentheses in case, if this was negative 4 and you subtract it, it'd be 3 minus a negative 4, which would be 3 plus 4. So by putting these parentheses around the bottom point, or if you want to even get technical, you can do this. That might even make it easier. You just make sure that you put parentheses around each point to signify that it's actually a point. If there's a negative coordinate in there, you'll be okay. What's 3 minus 0? 3. What's 3 minus 4? Negative 1. Now, this guy is my change in x, or delta x. This guy right here is my delta y. So, how do you build your slope? Delta y over delta x. Just put the negative 1 over 3, and you got your slope. Now, the nice thing about doing this is I'll say this. You can reduce the slope if you want to. If this was like 2 over 6, negative 2 over 6, you'd put negative 1/3 afterwards. So you can reduce the slope to make it a little bit easier to deal with, but it's still going to work. But you want to use these original values that you get from this, because once you get delta y over delta x in its raw form, the length of AB is really going to be delta x minus delta y. Delta x squared minus delta y squared. Sorry about that. I forgot about the whole square thing. So, what was my delta x? What was my change in x? 3. So I know I'm going to get 3 squared minus, and my change in y was 1, so that's a negative 1, so it's negative 1 squared. So now AB is going to be, well, what's 3 times 3? 9. And what's negative 1 times negative 1? 1. So it's 8, or it's 9 minus 1, which is the square root of 8. So AB is equal to the square root of 8. And if you want to simplify this, Can I turn this into a product where one of the numbers is one of the factors is a perfect square?
Can you just leave it at 8?
4 times 2. Well, sometimes you'll be asked to simplify your final answer. Now, I'm okay with this at times, but sometimes I'll ask you to simplify it. So being able to simplify your square root is going to be helpful as well. So what's the square root of 4? 2. So it's 2 times the square root of 2. But it's also equal to the square root of 8. They're the same thing. So you can figure out your length those ways. And instead of remembering this formula, you can remember just your table of values is going to give you not only the 2 parts for your slope, it's going to give you the 2 parts for the distance formula as well. So it's 2 pieces of vital information in one. Yeah.
What's this video going to be called?
What was that?
What's this going to be called? From the YouTube?
I haven't decided yet. I haven't put a title on it yet. Alright, for BC, for segment BC, we're going to do the same thing. Make an XY table. B is at 0, 4. C is at 0, 0. Subtract those. 0 minus 0 is 0. 4 minus 0 is 4. So my slope is going to be, again, delta y over delta x. Well, what's the change in y? 4 over 0. Can I divide by 0? No. So this is undefined. So when you divide by 0, you get undefined. And remember, your undefined slope for a segment, that's this guy right here. A vertical line. So this tells me that this is a vertical line. Now, if you remember that, and you take a look at BC and you say, oh, it's vertical. Well, you could come up with the slope that says it's undefined. Now, if you want to find the length of BC, if we use the formula, you're going to get 0 squared minus, actually it's plus, sorry. Alright, oh man, I screwed up the first one. Why didn't you say anything? You should have said, hey, you messed it up. It's okay. But at least a couple people saw it. Do you subtract off in the distance formula? No, you add. Why? Because what's it? What theorem is this? No, I just messed up the answer. And if I wasn't recording it, then you'd have no proof. Unfortunately, you have a ton of proof now. But I was just seeing if you guys knew what we were doing. Distance formula, you add. Because what theorem is this mirroring? Starts with a P. The Pythagorean theorem. Absolutely. So this is a squared plus b squared equals c squared. That's what it ends up being. I just happened to screw it all up. It's early. So what would actually be in the square root for the top one? 10. Now can you simplify 10? The only thing you could do is 5 times 2, and none of those are perfect squares. So your answer would be 10. So as soon as that dries, I'll put a 10 in there. So I'll say square root of 10. Now here we add them up. So this is going to be 4 squared. So this is going to be the square root of, what's 0 squared? 0. 4 squared is 16. So I don't have to put the 0. What's the square root of 16? 4. All right. Could we have just taken that off the picture? Off the graph itself? To see, no, well, 1 to see if it's undefined, but 2 to see also the length of segment BC. Yeah. If it's vertical, or horizontal, where M is undefined or M is equal to 0. You can just go, and as long as it's not diagonal, basically if it's not diagonal, you could just count the spaces. 1, 2, 3, 4. You would have got the same answer there. And for AC, is AC vertical, horizontal, or is it diagonal? It's diagonal. So I need to make my XY chart. Now here's the thing. If you always make the XY chart, you're always going to get the right answer. If you always use the distance formula, you're always going to get the right answer. So you don't have to actually have the graph in order to get the right answer. I put the graph on there to be nice. My X value for A is 3, 3. For C, it's 0, 0. That's nice and neat. 3 minus 0 is what? 3. 3 minus 0 is 3. So what's my slope? It's the change in y over the change in x. What's the change in y? 3. What's the change in x? 3. 3 over 3 is 1. But now for the distance formula for AC, I have to take my x value, square it, plus my y value, square it. Now here, if we use just 1 or anything like that, if we could have reduced this to 1 over 1, we wouldn't get the distance. We have to use, for the distance formula, use the raw data. And the raw data is this stuff right here. So you always have to use the raw data. So what's 3 squared? 9. And then another 9. So can I write this as 9 times 2? Alright, so instead of saying, square root of 18, which it is, isn't it? I went to 9 times 2 because 9 is what? Well, 9 is what we call a square, or a perfect square. What's the square root of 9? 3. So I can bring that out and get 3 times the square root of 2. So we got our answers there. Does that make sense? Now, a couple other ways you could have done this to get your slope. You could have went right from the picture if I just gave you the picture and I said, all right, if I covered all this up and said, give me the slope of AB and the distance of AB, then you can take from B and you can figure out how to get to A. That's 1, 2, 3. Am I going in a positive or negative direction? Positive. So that's positive 3. And now I'm went down 1. Is that positive or negative? Negative. So it's a negative 1. So which one's my y value? Is it the negative 1 or the 3? The negative 1. So I could have said that the slope of AB is equal to negative 1 over 3, and isn't that the slope that we got here? Same slope that we got here by creating a right triangle. Now, by creating the right triangle here, and I'm not going to do that for AC because you can do that on your own. But for this, I can say to myself, all right, 3 squared. And the nice thing about the right triangles, all you have to do is use the number, not the sign. 3 squared plus 1 squared is equal to AC squared. So that's 9 plus 1 is equal to AC squared. 10 is equal to AC squared. So AC is equal to the square root of 10. So you can use a Pythagorean theorem instead of the distance formula, which is pretty much, the distance formula is right here. AC is equal to the square root of stuff. And you just do the Pythagorean theorem stuff inside the square root. So the distance formula and the Pythagorean theorem are exactly the same. It's just when you do the stuff, where you put it, what type of formula you use. But they're the same. And even here, since I have some space over here, I'll just show you in red really quick. You could have said that 3 squared plus negative 1 squared is equal to AB squared. You could have just taken that value squared plus that value squared is equal to that squared. Then you get AB squared. That's 9 plus 1. So that's 10 is equal to AB squared. So AB is equal to the square root of 10, which is just what we did here. So there's so many different parallels between not only the Pythagorean theorem, the distance formula. They're the same. They're not even parallel. They are the same thing. It's just going at the problem from this way or this way. You're still going to get to that same formula that you need to use. Yes, sir. No. As long as you use one and use it correctly, I don't care which one you use. And that's my whole thing. As long as you can back up what you do mathematically, instead of just, and even sometimes you can pull stuff out of thin air and say, wait a second, this works. Then, if you want, we can go back and try and justify it mathematically, and we can figure out something new. Nothing wrong with that. I'm pretty sure we don't know everything yet. Even though they tried to close the patent office in like 1890. You ever hear that story? In 1890, they thought humans had invented everything that was going to be invented. Now imagine how far we've gone from 1890 to now. Where on my nightstand I have 3 different generations of iPads sitting.